Hi, this is Hema Kadia from TeckNexus. Welcome to the 5G Fireside Chat series. Our today's topic is Lean NFV, and we are going to talk about how Lean NFV can accelerate both the adoption of ETSI NFV as well as the deployment of 5G. For this topic, we are going to speak with Dan Pitt, who was Senior VP at MEF. He's currently President at Palo Alto Innovation Advisors and Executive in Residence at Plug and Play Tech Center. Welcome, Dan.
Thank you, Hema.
Dan, you want to add a few words about yourself?
Sure. I have enjoyed a really enjoyable and diverse career, but I've spent a lot of the time in, I'd say, open networking, from networking standards, technologies, interoperability between vendors, and creation of some important technologies. And I've been explicitly involved in the open networking movement for about 10 years. When I started to get involved in ONF before we launched it publicly, and I joined the Open Networking Foundation as the executive director when we launched it publicly in 2011. And that really created the software-defined networking SDN movement. And it's taken many flavors in many directions, and it's sort of how networking is done. And in 2016, late in the year, I moved over to the MEF forum, the former Metro Ethernet forum, which has 100 plus telecom service providers among the membership of 200 companies that really wanted to deploy open networking solutions. So I wanted to take it into the market. And along the way, of course, NFV joined the whole party. And I've been involved with that really since it was launched as well. So I'm always excited to see new technologies move into the commercial world to benefit customers and real people.
Thanks, Dan, for the introduction. Then let's start with what is NFV and what is Lean NFV and what are the key business drivers of Lean NFV?
So let's talk about NFV. Network Functions Virtualization was a movement started and launched actually next month will be 8 years at the 2012 what was called the Layer 1, 2, 3 SDN and OpenFlow World Congress. And it kept that name for quite a few years, and then it became the SDN and NFV World Congress. And this year, next month, it will be just the Layer 1, 2, 3 World Congress. It was launched in October of 2012 in Darmstadt, Germany, as an industry specification group, an ISG of ETSI, the European Telecommunication Standards Institute. And it really set the industry on notice that for the telecom industry to move faster and serve customers better, not have industry or service specific infrastructures, they had to virtualize what they did. And so that started the whole movement to virtualize network functions. So instead of buying a set of appliances and individual appliances for every function, they would virtualize the functions that they needed, and they'd run them in commodity servers in data centers. And it was a brilliant and great idea. And ETSI has served the industry extremely well by doing it. And yet 8 years later, it's not as widely deployed as we would have liked. So that the driver for Lean NFV is that the communication service providers really have to cloudify and virtualize their internal operations and the way they offer services to their customers. And we think of mainly enterprise customers and industrial customers, but also to offer services to consumers. So they have to do this. If we look at the future of those operators, 5G is a huge component of their future, and they're really betting on it. And it's bringing the promise that we have all hoped for the kind of services that we would be able to access. But 5G is going to need SDN and NFV to be successful, and we see that coming. But if we can't deploy NFV easily, we're going to find a hard time deploying and introducing 5G, and with novel services, not just a few basic connectivity services. And finally, the key essence, the fun part about NFV is VNFs, the virtualized network functions. and it says virtual, it can be containerized. We're not distinguishing between VMs and containers here. And I remember doing a study a few years ago about, do we need to standardize something about VNFs? And the answer was no, there's no way we can standardize it because they all run in different environments. And so I was hoping for an explosion in third-party authored VNFs to meet certain niche opportunities in the market, what people would want to do certain functions. That hasn't really happened. We don't have a write once, run anywhere VNF marketplace yet. And we're going to need this because of the novelty of services that customers are requiring that have to run on a common infrastructure from the telecom service providers. So that's sort of what's driven this effort that's called Lean NFV. And it really is just a simple way to implement and to deploy NFV. Network functions virtualization is important for the future of the industry, but we have to be able to deploy it more simply. And so we're bringing sort of an architectural openness to it in a simpler fashion, minimally invasive, the points that you see on here. So it can be added, and it is being added, and it's now an industry movement that's going on. And I'm grateful for the opportunity to share it with your viewers today, Hema, because I think the industry will find it beneficial.
Yeah. Then the two key drivers that I really take away from this particular slide is one being how it can really help or ease the NFV deployment and create an open VNF marketplace. Let's compare the two architecture in context of those two business drivers. I guess you have a ETSI NFV architecture almost 7-8 years back that we had defined. Of course, there is a new additions to that with the service-based architecture from an 5G perspective, but still overall, this is the architecture that it started with. And if now we bring in Lean NFV, let's compare how they look side by side and how exactly with the Lean NFV, we can accelerate the deployment of existing NFV deployments.
Sure. I mean, the ETSI architecture has been so instrumental in promoting the understanding of NFV as a concept. And so by defining these components here, they've really taught the telecom industry to think more like the computing industry.
Yes.
And so that's useful. And what we have on the left side is the ETSI NFV and the MANO management and orchestration picture. And we have the different kinds of components that you see there. And we have the VNFs, the virtualized network functions, and the element management systems, the EMSs, and so on. And then, of course, we have on the right the NFVO and the VNFM and the VIM. Now, on the right side of the left-hand picture. Now, on the right side, we have a picture of Lean NFV. It was on the last slide. We didn't talk about it. And it's an implementation of this that really simplifies how these things are integrated. So we have the three main components of the infrastructure manager, the VIM, the VNFs, and the NFV manager, which is a combination of the VNF manager and the NFV orchestrator, the NFVO. And what people tried to do initially is build these all very tightly and create standards and bilateral interfaces among every pair of devices. And consequently, the NFV management got embedded in the compute infrastructure, so it's very hard to change. And new features required changes in the pairwise APIs, because there were all these pairwise APIs. And that's, I think, what has held back the independence of the VNF. So we have done a couple things on the right side. First of all, instead of having really integration different for every infrastructure example and every VNF, we've simplified it by making something called the key value store a universal integration mechanism. Everything interfaces to that, and it's steady and it's constant, and they don't have to negotiate interfaces among the pairs of components. And then with that, by keeping the NFV specific features out of the VIM, we can now really translate and implement the NFVO, the VNFM, and the VIM as a series of independent, what we call microcontrollers.
Mhm.
And these are code modules that do certain functions, and you can create them once, you can apply them, and they really exchange state with the VNFs and the EMSs and the compute and switching infrastructure simply through the control plane interfaces of the key value store, or the KVS. So it's an implementation that says we're going to do these as independent modules that have a universal integration mechanism. And it's very simple. And I think will proliferate not only VNFs as an open marketplace, but also the microcontrollers, as you see on the right side, whether they're service chaining, placement, launching, these functions that are important for deployment. This is not theoretical stuff, Hema. This is how you get services out there.
So then from a VNF vendor perspective, basically what we are alluding to is that they can bring in their VNF and it may only need an integration with Lean NFV. And Lean NFV would really be the key integration points, whether it's a northbound, southbound, or east-west based upon the different components in the operator ecosystem.
Right, it would be the interface to the key value store. It would be the API. And it'd be a universal API to a key value store.
So this is one way of addressing the interoperability issue that we really see in the market when we are looking for NFV adoption.
Absolutely. And it certainly allows a telecom operator to go shopping and to build an infrastructure confident that any of the functions they want, either as microcontrollers or as VNFs or CNFs, will plug into it. So it's going to simplify their investment. It'll speed their deployment. And I think it's going to foster growth in very cool VNFs and microcontrollers.
Understood. So let's again drill down on, we know industry perspective, what is key value store, but let's understand from a Lean NFV perspective, how we are leveraging key value store in context of NFV deployment.
Yeah, we did not invent this, and I'm not an inventor of this, either. The key value store has been around for a while. It just stores keys and values, and you can get the information you need by looking up the key and extracting the value. Or you can write the value, you can read the value, and it's a very simple mechanism. That's there. Open source versions. etcd is a very popular one. It's deployed in many industries. It's not new. It's a very useful computing construct that we're applying to the world of telecom.
Understood. So going forward, like Dan, in this, as you've highlighted in this diagram, VNF vendor will need to predominantly configure their product in the key value store, whether it's for integration northbound with NFPO or OSS, BSS applications, or southbound with the existing NMS, EMS, BIM, or whatever ecosystem components. As long as they are able to configure it, whether it is for service chaining or for discovering or any specific place where they need to integrate in the ecosystem, as long as they configure, that's the key differentiator if I see from ETSI NFV to what Lean NFV is bringing to the table.
That's the goal. That's absolutely the goal. The devil will be in the details, and yes, we're hammering stuff out, and we'll talk at the end about where that work is going on. But what we're trying to hammer out is a standard method of communicating these control plane flows. And that should make it easy to write once and run anywhere.
So we've been talking a lot about VNFs. Let's spend a few minutes on how VNF is onboarded on ETSI MANO versus how it is going to be in Lean NFV.
Right, and it's not, it's sort of a misnomer to say this is ETSI MANO. ETSI MANO is this concept, and it's been implemented way too often with these integrated components. So the VNF manager is monolithic, and every VNF is customized to its vendor's EMS,
yes,
and to the NFV infrastructure,
yes,
and to the VNF manager. And so if you want to introduce something new or you want to change something, you have to change all of these components. They're tightly integrated, but it's not like it's a a really beautifully architected tight integration where you need tight integration. It's kind of a spaghetti, to me more like a spaghetti integration of too many things are tied into too many other things. What we're trying to show on the right is that you write your VNF and you have this API to a key value store, defining those. And you don't have to do it to the the something monolithic like the VNF manager. These microcontrollers that constitute the subcomponents of the NFVO and the VIM and the VNFM are also written once. And they can perform the functions that they need when needed. In fact, they can be invoked in a dynamic fashion as the VNFs need to call on them.
Understood. Hey, then I see in both the pictures and both the diagrams, we have VNF manager. I understand that, yes, today, as you rightly mentioned, most of the VNF vendors bring in their VNF manager. But I see the VNF manager also in the Lean NFV diagram. I'm assuming that is just to accelerate the deployment of the existing NFVs, NFV ecosystem, rather than re-architecting the entire VNF architecture. It's just that you can now take the VNF, and as long as you configure into the Lean NFV architecture, the deployment should be able to, the ecosystem should be able to integrate and work with it.
Yeah, that's right. By sort of deconstructing the VNF manager into the functions we saw on the previous slide as the different microcontrollers, you can create those as purpose-specific code modules.
Okay.
And you can write them for the functions that you need to implement. And you don't write them tied into a particular VNF that is involved in that. For example, you want to chain some VNFs together for a particular service chain. You don't have to write that function, that microcontroller specific to the functions you want to chain.
Got it. Okay, I think that's a good overview of what is Lean NFV and how it is comparing with ETSI NFV and how it will accelerate it. Let's re-summarize why Lean NFV. I think we've highlighted key points, but maybe it would be good to just summarize.
Sure, and I want to make these slides available to your viewers so they can go through them, at their pace. I don't want to read through everything, but the real goal is to really accelerate this virtualization and cloudification of telco operations and services, so that they can roll out new services wherever the network they are, and take advantage of standard computing platforms and an army of independent programmers who can bring these to market. And the key to this is having this Lean NFV architecture that simplifies the integration by making the key value store really the primary mechanism and universal mechanism for this integration. And resource efficiency, that's a general term, but it certainly applies to what it takes to deploy and manage this on the part of a communication service provider. But it also applies to the VNF authors and the companies that want to deploy these services and the microcontrollers. You can focus on the inherent function of your VNF or your microcontroller without spending 30 to 70% of your effort on integrating it into the rest of the infrastructure. And because we realize that unlike a lot of the hyperscale web providers that have brand new build outs, the telcos all have brownfield infrastructure. So these can be added really incrementally to an existing infrastructure. They'll certainly work with existing infrastructures and deployments. But I think once someone starts deploying these, as we know some operators are, they don't want to deploy any of the others in the older way of doing so. So there's some basic things that are happening now that'll pave the way, and then there is much more that we can do to really create a vibrant infrastructure that will help to move the telecom industry into the realm of computing. And that's going to be a big part of 5G.
Yes, yes. So then I think we address the aspects of how Lean NFV would definitely accelerate NFV deployments. But let's add what is an additional value if we think about from a 5G perspective. What is an add-on features that Lean NFV is bringing that would accelerate 5G deployments?
So we hear about what 5G really needs. And, I think one of the things I like about 5G and, the business case, I was on there was a talk this morning at the big 5G event about that. You can debate the business cases of 5G and the consumer market and the industrial market and the commercial market.
Mm-hmm.
And hopefully some of those things will get out there. But I think it's a big driver for deployment of SDN and NFV.
Yes.
And for the transition to computing instead of networking as really the heart and soul of the telecom industry. So that's why you need service-based architectures. You need microservices, especially if you look at the diversity of 5G applications.
Mm-hmm.
I mean, there's so many of the three big corners, but beyond that, there are so many variations. You can't have complex integrated infrastructures for each service. That's why a microservices architecture
Mm-hmm.
for implementing the endpoints of 5G is going to be essential. Cloud native, vendor independent, highly distributed. As I think we have a slide coming up on this.
Yeah.
Where might you deploy, not just Lean NFV, but NFV in general? It's in lots of places. And you want to have the freedom and the agility. And agility is really important here. To put the computing tasks where they need to be. And that could be very close to the customer if you have a very low latency requirement. Mm-hmm. It could be in a big central core database if it requires just a whole lot of, say, accelerator technology. Mm-hmm. And you may want to move these workloads around. And that's really what virtualization has brought to the computing industry. And we're bringing it to the telecom industry. We can go back one slide. There were a couple of points there that are probably worth mentioning. Yeah. The fact that we can create, on sort of the middle way through, aggregation at the mobile edge, and that includes both the service provider edge and the user edge, and these edge clouds and these cloudlets. And by having really an agile way of moving workloads around mm-hmm. to do particular functions that you need, you can enable the satisfaction of different service requirements. And finally, control plane, user plane separation. Well, this is, this was given as we have to do this. They didn't say how. 3GPP said it's just an essential part of 5G. Well, this makes that possible. And not only makes it possible, it makes it easy. And finally, I think it's going to be very useful in slicing and splicing. And splicing is where you attach different slices, different parts of the network, where you can actually implement a key value store per slice if you need it, or per service provider if you have multiples, or even per tenant if you have multiple tenants in some kind of a shared infrastructure. So we can go actually to the next slide and take a look at some of these places. So I think the provider edge and the user edge are getting a little bit blurred. I'm working with a company that does this on the customer premises. And in some cases, it's considered the user edge because the user owns it and manages it. In other cases, it's the provider edge because the provider manages it. I've also like to mention private 5G. I think we're going to see a lot of this before we see, a huge, record of deployment in public networks, because the private 5G brings particular benefits to industrial customers that don't have good networking otherwise, and this gives them a very focused solution that can be deployed quickly. And so the operators and the vendors are fostering this really as we speak. I think we'll see much more function at the cell site, and the cell site is sometimes on a tower, and sometimes it's in street furniture nearby. And this stuff can be pretty powerful, and you can put some compute infrastructure there. And I think you'll see more compute infrastructure there where you need it to be very close to a workload. Now, we haven't yet seen exactly what those workloads are that require something that close to the source of the data, but I think those will come over time. I mentioned these 5G island gateways. Well, what is that? A lot of 5G is being built out in certain places where you have as a last mile technology, and you can reach other endpoints in that island of 5G connectivity, but you'll need to communicate with the whole world. So how do you get out of that to other things with preservation, if possible, of your quality of service and your service level agreement? And this is where you might have slicing or splicing to really make the transition from one sub-network segment to another. Now, if you take that further, I just mentioned the inter-provider gateways. We have seen in the deployment of the Sonata East-West API in MEF that carriers are concatenating services in an automated fashion that does not take months to set up. It takes seconds or minutes to set up. And where they have these inter-provider gateways, they have to manage their services and their business. And these functions are going to be dynamic, containerized, virtualized network functions. And this is a good place, I think, where we'll see this deployed. And if you want NFV, you're going to use NFV, I'm not sure I know of a better way of building and deploying NFV. So wherever NFV is sold, I think we'll see opportunities for Lean NFV to make a tangible difference.
Then on the previous slide, you highlighted few architecture aspects of Lean NFV, and on this slide, we are discussing the deployment, the various deployment modes in which Lean NFV can be deployed. Is this already supported out of box? Like, where do we stand from that perspective? The current.
Yes, I mean, there are companies that are starting to serve customers. I'm not really at liberty to say what they're actually doing, but the number one thing people want to do is to onboard VNFs.
Yes.
In an automated fashion very quickly. There have been competitions over the last 3 years of how quickly can you onboard a VNF. It's been like 3 months, 3 weeks, 17 hours. That was tremendous. This is ridiculous. We need to deploy like any other piece of code. So that's where the current implementations are focusing, and the service chaining of the VNFs. And then scaling and change management, and the things that you have to do in the lower bullets about making sure that you can maintain an SLA for your customer by knowing what's going on and being able to react to what's going on.
Understood. And you've highlighted the future areas. Is there already a roadmap defined from a timeline perspective when we can see those features as well?
First of all, these are increasingly vendor-specific plans.
Okay.
And so there's no general industry area. We will see in the standards activity that the essential framework is being put in place now. When that gets there, we'll get a little bit of experience with it, and we'll expand to other use cases and additional deeper capabilities.
Understood. And I think the last question, how is Lean NFV related to MEF? Like, what's MEF role in the entire Lean NFV project?
So Lean NFV was launched at the Open Networking Summit in April of 2019 in San Jose. And they created this thing called leannfv.org, and you can go to it and you can read the white paper and you can see the video, although there might be a new link to the video. It's on YouTube. It's no longer on Vimeo. And they created leannfv.org, and they got signatories to the original white paper, but they didn't want to build an organization. They didn't want to hire people, have budget and membership and all of that complexity. So they went around the industry to see where could we move this to some kind of an industry forum, consortium, standards organization to get industry agreement on how we might do it initially. And they shopped around and they talked to lots of people. And then this spring they decided they're going to come into MEF. And so that was launched in April as what was called an incubation group. And that has to meet certain milestones. And so they launched it, and then it has to go through these milestones to become an approved project. And in this case, it's the LSO committee, Lifecycle Service Orchestration Committee in MEF, was assigned a draft specification number of W120. That was approved the final week of July. So it's now an official project, and there are weekly calls on it. And they're developing, a number of the companies involved are developing a POC related to a SASE application, the Secure Access Service Edge. In January, I think we're going to have these first POCs. It'll probably be part of the, could be part of the Infinite Edge project of MEF. And the specification is developing these control plane APIs and the schema. So they're working on the schema now. And I estimate that they'll have a letter ballot on that no later than the second quarter of next year, and hopefully sooner. And that letter ballot will be version 1. And once that's done, and it's, we get the, experience and some feedback, then we'll take it to version 2 and do some additional things on it. So, so it is an official plan project in MEF. We have weekly calls. Any member company can send any number of people to the calls and can participate in a POC. And this is just the first one. We expect there will be others over time as people demonstrate how it can be used. So I want to direct people not only to the leannfv.org website, but come to the MEF website. And there's a website here for all the white papers. And the last I looked, it was like the second one down, and it's open to the public. And anyone can read that white paper. So it's now moving forward with a really strong industry participation led by a number of operators and a number of vendors.
Thank you, Dan, very much for this very informative session.
You're welcome, Hema. I hope that this really helps the industry. I think it's a really good and useful insight in how you can take a great idea like NFV and simplify its deployment and implementation. And I really hope to invite all interested parties to take a look and get involved, join if you wish, or when it gets published, it becomes a public standard and anybody can use it free of charge.
Absolutely. Thank you very much, Dan. Really appreciate your time.
You're most welcome, Hema. Nice to talk with you.
Likewise.